Alright, what's up Pre-Algebra? Welcome to a lesson on how to graph linear equations. Now I'm going to show you two methods today. This is for my Pre-Algebra class at Millennium High School, but if you're anyone that's stumbled upon this video, feel free to stick around and learn some stuff. And what we're going to do today is I'm going to give you a little bit of background on what a function is and a graph, and then we're going to just jump right into it. Not going to be super long. This is a review for my class, so you should know what to do, but if you don't, pay close attention and pause this video when you need to just pause and think about it, okay? So before we start, let's talk about what a function even is, right? This is an equation, it's also a function. So how can we graph this? Well, first off, we have to just think about a graph, right? So a graph has two axes. One of them is the y-axis, that's this guy. That's the vertical, up and down. And the other one is the x-axis. That's the horizontal. This is the x-axis, okay? So we think of a function, there's two variables, a y and an x, and we think of it as an input yields us an output, okay? So let's think of a function machine. This is a nifty way to figure out what a function is. So let's create this little machine right here. So inside, this is our function. This is a little machine, and what we're going to input into the function is going to be our x values. Okay, so where's the x on the graph? The x on the graph is all these x values, any one of these x values. What we're going to do is we're going to input that into our function, right? And then our function's going to do some stuff. It's going to go chug a chug chug, and it's going to output a y value, okay? So these y values are dependent on the x value. That's why we call x the independent variable and the y is the dependent variable, okay? So if I pick any random point here, what do you guys want to pick? Let's just pick a random point on the x-axis. We can be positive or negative. Let's pick this point 3, okay? This is 1, that's 2, and this is 3. If I pick this point 3 and I input it into a random function, well, we have to have a function first. What are we going to get as a result? Let's create a new function. Let's just create a random function. Let's say y equals 2x. This is a function, right? It's an equation. It's a linear. This is a linear function because the exponent on x is 1, right? There's a 1 right there. That's why we call this linear. Okay, but if it's just a 1, you don't need to put that there, so we can just erase that. Now let's do the same thing. Let's take this function machine. But now let's create the function that we just said right here, okay? So over here we're going to put 2x, okay? That's the function that we've created. Now up here, these are our inputs, okay? So these are our x inputs. So this is a line. If I graphed it, it's a line on the graph. Now we can create that line by taking any random x value. So I can take any one of these x's. I could take 1, 2, or 3, or 4, or 5, or -1. I could take any one. Take any one of them and then put them right here as your input. Let's take 3, okay? So take this, put it there, and then what happens? We just said that x is 3, okay? So this x right here is now going to change to a 3. We just chose it. And now what do we get? We get 2 times 3. So what's our output, right? What's our y value? What's 2 times 3? 2 times 3 is 6, okay? So 3 was the independent variable, the x, and it yields us 6. Does that make sense? So what you can do is we've just generated one point. When x equals 3, y is 6, right? So we've created this point. We've created this point, 3 for the x variable, comma 6. That's our x, and that's our y. Okay, so we can graph that point. That's 1 point, and we probably need 2 or 3 more to make a line. Okay, you actually only need 2 points to make a line, but let's get a couple more just so we can see it. So let's go over here, and we have 1 point. That's 1, 2, 3, and then we go up 1, 2, 3, 4, 5, 6. Okay? Now remember, we're saving this for later. This is for later. Okay, back to our example that we're doing right now. Let's find another point. Okay, let's get 3 of them. So we just picked this number 3. Let's pick this number 2. What happens if I take this number 2 and I input it into my function machine? Okay, you can just input it right there into that equation. You don't have to do the function machine every time. That's just an example for you to see. If I take 2 and put it right there, I get y equals 2 times 2, right? So y equals 4. So when x equals 2, y equals 4. Okay, so let's graph that point. When x equals 2, y equals 4. So that means when x equals 2, I go up 1, 2, 3, 4. Okay, now let's grab this point right here, 1. So what happens when I put that right there? So I'd get y equals 2 times 1. So I get y equals 2, because 2 times 1 is 2, right? So when x equals 1, y equals 2. See that? Now I have another point that I can graph. I go on the x-axis, 1, and I go on the y-axis, 2. 1, 2. Okay, and then you can graph that. That's a line. So just put a line through each one of those points and keep going forever. And you've graphed a line. Okay? That's the basic bare bones way how to do this. Now we're going to look at it using 2 specific methods. Okay? This is your homework. If you're in my pre-algebra class, I'm going to do your first 2 problems of your homework. Okay? We have 2 different methods of graphing linear equations. Okay? Method 1 is an x, y chart, and we can also call that a function table. Method 2 is slope-intercept form. We can just plot the y-intercept and then use rise over run if we have the slope. Okay? So let's look at problem 1 on our homework. Okay? So problem 1 says y equals 1/3 x minus 2. Now the first way, let's use the method 1. So what we have is what we're going to do is we're going to do an x, y chart, okay, or a function table. So you just write x and you write y. Okay, now let's just create a couple x points, all right? So let's create -3, 0, 3, and 6. Okay, so these are our inputs, right? So if I input -3 into 1/3 x, right, what is this going to simplify to give me my y value? All right, well, I'm going to input it over here. I'll do my scratch work on the left side, okay? So I would get y equals 1/3, and then this is where I input my x value, times -3 minus 2. Okay? Now this 3 is going to cross cancel with that -3. If you don't see that, just put it over 1 and multiply straight across. So you get y equals -3 over 3 times 1 is 3 minus 2. What's 3 divided by 3? That's -1. So that equals -1 minus 2, and that gives us -3. Okay? So for the x point, -3, we're going to get an output of -3. Now over here on my graph, I can plot that point. So I get 1, 2, 3, negative 1, negative 2, negative 3, and then negative 1, negative 2, negative 3. So right there, I'm going to get that point, negative 3, negative 3. Now if I plug in 0, anything times 0 is 0. So I'm going to get y equals 1/3 times 0 minus 2. So that's going to give me 0 minus 2, which is just negative 2. So right here, I'm going to get negative 2. So let's plot that point. 0 for the x, right? This is saying my x value. So I'm not going negative or positive. I'm staying at 0. And then I'm going to go negative 1, negative 2. So right there is my next point. Okay, right there on the y-axis. Now let's plot the next point. So 3 is going to go up there. So I'm going to get y equals 1/3 times 3 minus 2. So those are going to cancel. So I'm just going to get y equals 1 minus 2. And that gives me negative 1. Okay, so if I'm going too fast, just pause the video and catch up. All right. So I get 3 and negative 1. So I go positive 1, positive 2, positive 3, and then drop down to negative 1. Okay. All right, one more point to go. I'm going to plug in a 6 right there. So I'm going to get y equals 1/3 times 6 minus 2. Now the 6 is going to be canceled off with the 3, so it's going to be 6 divided by 3, which equals 2. If you can't see that, just do it the long way. That equals 1 times 6, which is 6, over 3 times 1, which is 3. What's 6 divided by 3? That's 2 minus 2. What's 2 minus 2? Is equal to 0, right? So over here for 6, I get 0 as an output. So that means I have to go 6 on the x and 0 on the y. So 1, 2, 3, 4, 5, and then let's extend this line a little bit longer. 6 is right there. And 0 is not up or down, but 0. Now I've graphed all my points. Now you just connect them all with a line. And that's how you graph the equation using method 1. Okay? Now let's use method 2. So method 2 is a little bit less work. Okay? So all we have is the same equation, but let's set it up again. Let's write it. So we have y equals 1/3 x minus 2. And before I run out of room, let me put my graph. Now method 2 is using slope-intercept form. Okay? So we have to use the skills that we've already learned. What is slope-intercept form? Slope-intercept form is y equals mx plus b. That's slope-intercept form. What's our m? M is slope. And b is our y-intercept. Okay? So we're pretty much good to go if we use this, because that's telling us that our slope is 1/3. Okay? So we have m equals 1/3. And what's our y-intercept? This is our y-intercept. Our y-intercept is -2, or the point 0 for x, -2 for y. Okay, so what you do using method 2 is you start by graphing the y-intercept. Okay, so what's the y-intercept? -2. So 0 for x, and then -1, -2 for y. Okay? Now, the next thing that you do, see how this is correlated with this? We have the same y-intercept. We better have the same y-intercept because it's the same function. Now what we do is we take our slope and we do rise over run, creating points. Okay, so rise is 1 and run is 3. So that means I'm going to rise 1 and then run 1, 2, 3. So I rise 1, run 1, 2, 3. Okay? Now let's do that again. Rise 1, run 1, 2, 3. Okay? But you see I've lost room. I don't have any more room to graph any more points. So here's a trick that you can do. You can continue this line in the opposite direction by, instead of doing a rise, if you want to go in the left, that's the negative direction. So you do not a rise, but a descending value of -1. So, and see how that's a positive one? If you want to go in the left direction, you just go -1, and then you go -3, right? So you just flip it on both sides. So you would go -1, and then +1 to, or -1 to 3. And that gives you that point right there. And we have all the points are the same, and you graph that, and you're good to go. Okay, that is how you graph an equation using two methods, XY chart and slope-intercept form. Okay? Let me do problem 2 for you on your homework. Okay? So for problem 2, we have y equals -2 x plus 5. Okay? And we're going to do method 1 first. Method 1 is the XY chart. So let's create an XY chart. And we're going to do -1, 0, 4, and 6. Just pick some random values that you're going to throw on your graph. This is my y-axis. This is my x. Okay, so I take this x input, and where's x in my equation? It's right there. So you just plug it in. All right? So I get y equals -2 times -1 plus 5. -2 times -1 is +3, and then I have that 5 over there, and that gives me 3 plus 5, which is 8. So I'm going to graph that point. I have -1 for x and +8 for y. So -1, and then +1, 2, 3, 4, 5, 6, 7, 8. Okay, all the way up there. Okay, my next point is 0. Now I'm going to plug that in. So if I get y equals -2 times 0, because that's my input, and then plus 5. Anything times 0 is 0. So I get 0 plus 5, which is just 5. Okay? So 0 is right there, and then I go up, +1, 2, 3, 4, 5. Now, next point is 4. So I'm going to get y equals -2 times 4, because I'm plugging it in from there, plus 5. -2 times 4 is -8. -8 plus 5. See how the negative is next to the bigger number. Since the negative is next to the bigger number, you're going to end up with a negative number as an answer. Because it's like you borrowed $8, so you're in debt $8, and then you pay back 5. You haven't paid back the full debt. You still owe $3. So I'm going to plot that point. Oh, sorry, I forgot to do that. And this was 4, -3. So I'm going to go 4, 1, 2, 3, 4. And then I'm going to go -3, -1, -2, -3. Okay. Now, I'm going to do my last point, which is y equals 6. Oh, sorry. Y equals -2 times 6 plus 5. So that equals -12 plus 5, which equals negative, what? -7. Okay, so at 6, we got -7. So you have to go +1, 2, 3, 4, 5, 6 on the x-axis, and then down 7. So it's -3, -4, -5, -6, -7. Okay, so my point is right somewhere about there. All right, and now we're done for method 1, because we have a line. Make those points a little bit bigger, and you graph it. And make sure that your line creates somewhat of a line. Your guys is going to be better because you have an actual graph, whereas mine is not perfectly to scale because I made these points myself. Your line becomes a little clearer and more straight if you make sure that each one of your grid boxes that you create on your own is the same distance. Okay, that's method 1. Now let's use method 2 and make sure we get the same thing. Okay, so we have y equals negative 2x plus 5. So here we have to identify what's our slope and what's our y-intercept. That's our slope, that negative 2, and that is the y-intercept. Okay, so let's graph this guy. So we start by graphing the y-intercept, which is 0, 5. We go up 1, 2, 3, 4, 5. Now our slope is rise over run. So slope, m equals negative 2. Well, remember, every number is always over 1. You can always put it as a fraction over 1. So our rise is negative 2. So that means we're going to be dropping negative 2, and then we're going to go over 1. Okay, so to the right one. So we start up here at 5, and then we drop 1, 2. So that was our rise of negative 2. Now we have to move over positive 1. Okay? Now from here, that was at negative 3, or positive 3. Now we drop negative 1, negative 2, and then we move over 1. Okay? Do the same thing, move over 1, or drop 1, 2, and then move over 1. Okay, and now drop 1, 2, 1, 2 over 1. Okay, that's enough points. You don't really need to do that many. And then you graph that as a line. And you're good to go. All right, guys, that is how you graph these linear equations using 2 different methods. Okay, these are the first 2 problems of your homework. Complete all of it, upload a picture to Google Classroom, and you're good to go. If you weren't someone in my class, hopefully this helped you out a little bit. Stick around and check out any other math videos that I will put out there, and good luck in all your math endeavors. All right, everybody, have a good day.